Lesson 7.3 in Algebra 2, we're going to be solving radical equations, not just with square roots, but with cube roots, fourth roots, and just want to streamline this process. We are going to have to do a check each time as we solve. Very important for us to discuss why. It's not a matter of did we make a mistake in the past. That's what a check would really be for. We might be able to see if we made a silly arithmetic mistake solving. This goes much further. The real question is there an answer to begin with? Take a look at example 2 here. We have a second root, a square root. That index is understood to be a 2. And to get rid of a square root, we will square both sides. By the way, to get rid of a third root or a cube root, you have to raise both sides to the third power. What we're really seeing is this index really will tell us what power we need to raise both sides to. So you square both sides very quickly. You'd have x is equal to 25. Now please be careful. What you actually want to do is determine if this is even an answer at all. So we're going to store 25. I'll hit 25 on the graphing calculator. Press the store button. It's right next to the 1. You see an arrow show up. Now press the X button. And I'm going to just type in the left side of our equation. I'm going to type in the square root second and then hit the x squared button right by the 7 on this diagonal. Then literally type in an x. If we're right, we should get an answer of 5. We do. We can say that our check works. Now, of course, you might wonder right now, well, my goodness, is a check really even necessary? Is it just wasting your time? It truly is. So let's look at number 3. By the way, your ultimate goal is always to isolate the radical first. Isolate the radical. Get that radical by itself. And you can see we have a 10 here multiplied to the square root of x. I'm going to do the opposite operation and divide by 10. Negative 90 divided by 10 is negative 9. Here we go again. To eliminate a square root, we will square both sides. Negative 9 times itself is positive 81. Notice also, if you're squaring, you should use parentheses. It's exceptionally tempting to say we're done, but we should check and see if this works. Here's what we're talking about. We obviously saw an answer of 81, so I'm going to type 81, store that in for x, and then we'll type in 10 square root of x. That was my original left-hand side. When you hit enter, you get positive 90, not negative 90. Your check fails. When you plug in 81 into that radical, the left side does not equal the right side. The correct answer is that there's no solution. And you can see how very important doing a check really is. You're going to realize that all of our work was correct. We did every step algebraically, perfectly correctly. The real issue is there an answer to begin with? If there is an answer, it's 81. Sad to say, there isn't even a solution at all here. For number 4, get your radical alone. You can add a 7 to both sides. You'd have radical y is equal to 5. How about we square the left side? We square the right side, and 2 to the second, you'd get a 4. By the way, even though you don't see a y button, y is above the 1. You'd have to hit alpha 1. And I just want to show you that that's always a possibility. First, you'd want to hit store for store, and then you'd hit alpha 1. And let's see if this checks. We'll hit second square root. I'll hit alpha y. Very important to leave the radical. If I type minus 7 right now, the -7 would go underneath the radical bar. So I hit the right arrow, so that I can make it look just right. You can see radical y minus 7 equals negative 5. Your check is good. Your check works. Your answer is y equals 4. Moving on to number 5, we can subtract a 4 from both sides to get our radical alone. To get that radical by itself, always deal with addition or subtraction before you divide. You'd have radical 3x equals negative 12. Now I'm going to square the left side and square the right side. And you will get 3x equals 144. And when you divide by 3, you're going to be able to get x is equal to 48. You can check that with a calculator. But I think more importantly, with our calculator, we should check even if that is possible. Let's take 48, put that in for x. And here we go again with being careful how we type out our check. The 3x is underneath the radical. Hit the right arrow to exit the radical bar. Type a plus 4. If we're right, we should get negative 8 for our answer. We actually get 16. There's no solution. Our check fails. So you have to be so very, very careful here. It's very easy to just move on and to go to a next problem. You very well might be seeing that, sadly, there is no solution. Let's take a look at number 6. I can minus a 5 from both sides. 3 minus 5 is negative 2. And I'll have the cube root of 2x. Here we go again. To get rid of a third root, a cube root, we're going to raise both sides to the third power. In other words, we're going to cube both sides. That index is so amazingly helpful. It tells you how to get rid of the radical. So the radical disappears. On the left, you'll just have 2x. Negative 2 to the third is negative 8. You can divide by 2, and you'll get negative 4. Now, I think you get the trend here. We should be very careful and say, you know what, we should check and see if this is going to work. Negative 4, put that in for x. Now we need a cube root. Hit math, come down to number 4. We'll say the cube root of 2x. Move that over, say plus 5. Hey, if it works, we should get 3, and we do. The check worked. So we are good. Move on to number 7. The radical is alone. And to get rid of a fourth root, I already have that fourth root by itself. I'm just going to raise both sides to the fourth power. Now 3 to the fourth is not 12. It's 3 times itself 4 times. You can check that out. It's 81. When I add a 1 to both sides, I'll get 82 equals 2x. I'm going to divide by 2, and x is 41. But here we go again. We need to do a check. A 41, we should store that in for x. And I'm going to make the fourth root appear. You might remember how we do that. First, you have to press the index. For fourth roots, fifth roots, and higher, you start with your index. You type in a 4. You hit math. Come down here to number 5, that x root. But when you hit enter, you're actually going to nicely see a fourth root written out. Then we just simply type in 2x minus 1. It's all underneath the radical. Hey, if it works, we should get 3. It does. Your check works. Now, we're skipping around a little bit. We're not going to be doing number 8 or number 9. And in fact, the last problem we're going to do is number 10. And number 10 is very, very, very different. You can see there isn't a radical explicitly written out. Of course, we could change fractional exponents into radicals, but listen, we don't even need to really do that. Instead, get x isolated, add a 2, and you'll have x to the 3 halves. And to get x alone, when you have a fractional power, to just have x to the first, raise both sides to the reciprocal power of that fraction. In other words, raise both sides to the 2/3 power. Reciprocals multiply. Remember, a power to a power multiplies out. You just have x to the first. And tell you what, 27 to the 2/3, you don't even really need parentheses. Just hit that caret button. It's above the division symbol. Alpha y equals makes a nice fraction show up. If we type in 27 to the 2/3, you'll get 9. But you might not be surprised. We actually need to do a check even here. So I'll take 9, store that in for x, and let's check that left-hand side. We'll go x, raise it up to the alpha y equals, we'll get 3 over 2. Move that completely over, hit that right arrow until we're back down outside of the powers. Then just type a -2. If we work out, if this checks, we should get 25. We do. So the check works. So that's lesson 7.3. Best of luck to you.